I'm going to talk about the challenge in automotive security. I work at Argus. We do cyber for automotive. And who saw the keynote yesterday by Michael Osman? Okay, so he inspired me to add this slide now, which was not in the original presentation. So who am I? I started, like most Israelis, in the army. I spent 18 years in military intelligence, doing a lot of cyber. And then when I quit the army, I went to work for Checkpoint. I started the malware research group and then vulnerability research. I was there for 3 years, moved on to Perimeter X, which is a web security startup. Now I work at Argus. Now what I added is the community part. Like Michael said, this is all part of a community, and one of the best ways to contribute is to volunteer. So I'm one of the co-organizers of B-Sides TLV, and I'm also trying to help whenever I can with organizing the Israeli chapter of the DEF CON. So you should do the same. Go contribute to the community, speak in conferences, volunteer in conferences. It's very important. And now to work. What is the problem? We all have cars, and most of us use it to transport the thing that is most important to us, right? Our family. And we also know that if something goes wrong, if someone hacks the car, then terrible things could happen, right? And we keep reading about research that gets published. I'm going to mention a lot of it here, but we don't really know, and they don't tell us why it's like that. Why do we keep seeing research coming out, and why are cars not secure, right? Because we see that all the time. Well, the answer is that cars are a very complex product. You guys are used to complex stuff because we're all doing, IT security and other stuff. It's all complicated, and we're used to that. But a car is an exceptionally complex product. Let's look at the list of suppliers. A car, if you didn't know, is basically an outsourcing project. When you buy a car from one of the vendor doesn't make the car. They make commonly, let's say, about 30% of the car, and everything else is made by Tier 1, Tier 2, and Tier 3 manufacturers. They make parts of the car, and then the manufacturer just puts it all together like a big puzzle. So this is a partial list of the subcontractors, the suppliers of a modern car. There are about 32 in that list, and that's not even a full list. And this is not just this car. All new cars look the same. So right off the bat, you have a lot of parts being produced by a lot of different manufacturers, and you have to put them all together. A modern car, has about 100, maybe 150 million lines of code. To give you perspective, this is more than what it took to fly the space shuttle. And maybe we're used to that because, you buy software today and it's gigs over gigs, but this is not trivial. This is a lot of code. And what do you have when you have a lot of code? You have bugs, right? So it is estimated, based on our talks with the community, that there are about 10,000 known bugs in a new car that rolls out. Okay, documented known bugs that were not fixed because they were not deemed important, there was not time, something else happened. The car rolls out with the bugs. Okay. However, the number of estimated unknown bugs in the same car, the brand new car that you just bought, is estimated at 50,000. Right? And who is going to look for all these bugs? The hackers and the security researchers. Because the manufacturers, they're busy with the next one. So it's a lot of code, right? A lot of code. Now, there was a very nice research done with the people who write the code for the car manufacturers. And they were asked, questions about security, how it is perceived, are they making it in a good way, are they aware of it? And, while this is from 2015, the results are not promising. When asked, secure software is a priority for my company, only 41% said yes. This is the people that make the car, right? I believe that securing the applications needed is difficult, or very difficult. So yes, 70% said, of course, it's difficult. But look at this. I believe that automakers are as knowledgeable about secure software development as the other industries. 72% said no. So the people that write the code for your car know they have a problem, right? So we had a lot of parts, we have a lot of code with many bugs. Let's move further. This is a rough map of a car, or the circuitry of a car, from 12 years ago. Okay? I will save you the counting. There's between 50 and 60 different little boxes. We call these boxes ECUs. And each one of these boxes does something to do with the car. It can be a small thing, it can be a big thing. And they're all connected. And if you look at the colors, you have like, 5, 6 different networks. So this is starting to be complicated. This is not just, putting 5 or 6 devices on the same network and having it all work together, right? And this is from 12 years ago. This is what a brand new electric car looks like, minus, the details because this is proprietary. But there are almost 200 different ECUs in a brand new car. And they all need to work together. And they're all made by different manufacturers, all right? Now, some of them, on the lower end of the scale, are not very sophisticated. This is called the TPMS, Tire Pressure Measurement System. And that's the little device that if you have a flat tire or something like that, there's this little light that pops on your dashboard, right? But even this device, right? These are the transmitters. They're in the tire, and this is the receiver that is somewhere in the engine. This is an IoT device with a radio transmitter and a firmware, right? So even this can be hacked. What can you do with that? Well, this is something that I'm working on right now, and maybe next year I'll tell you. On the far end, the higher end of the scale, is this. This is what we call the infotainment. Now everybody has that in their car. And if you notice, then in modern cars, this is not only the radio and playing music and stuff. This controls the air conditioning. You get to set up parts of your car, maybe anti-skid and all sorts of sophisticated stuff. It all happens on the same computer. Now this thing is a full-fledged computer with sometimes 2 to 3 different CPUs with multiple core running modern operating systems like Linux or Android. So this is pretty much a laptop, okay, like your home computer. This is how complicated and complex this product is, right? And those were the devices. As I mentioned before, you have 5 or 6 different types of networks in a car. It's not like in an office where you have the wired network and then the wireless network and they're pretty much the same thing. No, there are a bunch of different networks with different standards. Because some networks have speed as the most important feature. For example, if you, God forbid, crash your car, then you want the crash sensors to pass the message to the airbag very, very quickly. We're talking like microseconds. However, when you drive your car, right, rear, you have this little camera, it's not important. 100 millisecond, 200 millisecond. Some cameras don't even send you a video stream. It's like a stream of single photos. You don't know that, you don't notice. So it doesn't matter, right? So depending on the functionality, some of it give you speed, some of it latency, but you have 5 or 6 different types of network. So this is also complicated. Now, the most important and historically most prevalent bus that they have in the car is called the CAN bus, right? It was mentioned yesterday. If any of you saw Stefan's talk about hacking yacht, same protocol. And this is an old thing, and the most important thing to understand, this is called the arbitration field. The arbitration field serves 2 purposes. First, it tells the rest of the world who you are, because this is a broadcast protocol. It says, hello, my ID number here is 10100. And the number is also the priority. The lower the number, the higher the priority. So if you're ID number 2, and then ID number 1 starts speaking, you have to shut up. That's the protocol. Now what you don't have here is any form of authentication. There is no way to know who actually sent that message. So if you get access to the CAN bus by any means, you can do message flooding, you can do impersonation, you can send commands that do things, control the car, maybe open the airbag. I don't know what it's like here, but in Israel, if the airbags deploy, the car is considered total loss. You have to get a new one. I mean, yes, they can replace it, but as far as insurance is concerned, total loss. You wrecked your car. Now, a car is also a very sophisticated process to follow. It takes roughly 5 years from the first idea of, okay, let's make a new car, until it actually rolls out. Because there is so much regulation that you have to follow. People drive cars, they risk their lives if something goes wrong. You have regulations over regulations on how to build stuff, how to write code, how to connect it, all the tests. You have the crash tests, and you have the QA and everything. And it takes 5 years, 5 long years, roughly, right? Sometimes it's more, sometimes it's less. But in those 5 years, you wrote software and it passed the test, so now it rolls out, but it's been 5 years. This is software from 5 years ago. So you already roll it out with problems that, might have been solved by now. Now, if you look at the lifespan, how long will the product be, on the road? A cell phone, roughly 2 years before, either it drops, you lose it, you break it, you get a new one, right? That's the average lifespan of a new smartphone. With computers, laptops aside, maybe 5 or 6 years before your desktop is like, okay, let's retire it. But a car will last, up to 15 years on the road, maybe even more. And they don't do software updates on a regular basis, so you can have a car on the road right now with software that was written 15 years ago. And I mentioned before that, it's using Linux. Linux has vulnerabilities, right? They get published. You have exploits and everything. And you're going to have a device running software from 15 years ago. So that's a big deal. Now, no updates. Today, with the exception of very few cars, if you have a problem, you have to go to the shop. They can't do, remote updates like Windows and other things. You have to go to the shop, and it's a big, big problem. You lose days of work, you lose time, maybe you lose money. The car shop, instead of, fixing people and charging them, they have to do this now. And of course, the manufacturer pays for everything. It's a big deal for everybody. Now, since we are security researchers, we're talking about attacking, right? Hackers. We look at everything as an attack vector. What are the ways to hack a car? And the simple truth is, any way at all which connects the car to the outside world, okay? Everything that is not part of the car is considered to be an attack vector. And there are many of those. Right from GPS, I don't know if you know, but right this year there was a research showing how to spoof GPS in a way that actually tricks navigation software on your mobile. If you watched the talk yesterday about the drones, then you already know about GPS spoofing, because that's how you trick the no-fly zone, right? Remote keyless entry. Just, I think a month ago, a group in Belgium in the university found a way to clone, the key of a Tesla. Because the manufacturer who was making the keys, which was not Tesla, was using a 40-bit encryption. So these guys did all the rainbow tables and all the calculations, and now they need 2 interrogations with the car, 2 interrogations with you, and then it takes them 1.6 seconds to break the key and create their own key. Now, we all know about relay attacks, right? So if you have an NFC key, then I can do a relay attack and drive away with the car, but I don't have the key. So unless I keep the relay, if I stop the car and I close it, I won't be able to get in. These guys made a copy of the key. So technically, it's a lot worse, right? So, power line communication, smart cars, electric cars, there's data going over that. There's a lot more. Vehicle to infrastructure, OBDs, the diagnostic port that you all have, that the car shop, they use it, to fix stuff, diagnosis. But the infotainment is even worse, because like we said before, this is a complete computer, and like any other computer that it has all the attack vectors. The wireless and the wired and the USB that you put in with your music, and an SD card for software update, and the cellular, all the attacks, even radio data system. When you hear the radio and then sometimes it'll show you the name of the station, there was also research that showed code execution over that. So everything in a car is an attack vector. Now the problem is that the industry, just like other industries, sadly, is rushing to connect. Today, connected is good. I don't know why. We know that it's not, but most people who are not us, they're like, oh, connected, that's good. It's usable. I can do stuff with that. I really enjoy the fact that I can, turn on the air conditioning in my home when I'm on the way. So when I get to my home, it's already air conditioned, right? For me, it's good as a consumer. But this whole let's make everything connected does not take into consideration the fact that there are problems. And I'm not even talking about the unknown threats, right? There are known threats that we all know that are still not being addressed, right? Now, this all sounds very theoretical. Like, yeah, there was research, blah, blah. This is actually happening. And now I'm going to share with you stories from real life. Everything that I've just said, let's prove it. So, fact of the matter is, no one is immune, pretty much. All the big manufacturers have been hacked one way or another. Sometimes it's the car, sometimes it's the back end. No one is immune, right? And academia has been looking at this for a very long time. This is a research from 2004, right? That's 14 years ago, talking about automotive security and automotive networks inside the car. They were already talking about that 14 years ago. And this is from this year, a research about what happens when you do a battery exhaustion attack on an electric car. What can you do with that? It has implications, right? You need to know that. But the tipping point, or what brought it all into the public eye, were these two guys, Chris and Charlie. First research in 2014 and the second in 2015. They showed remote code execution over the internet on a car. Now, you need to think about that for a second. If you haven't read these two researchers, you should. By the way, they published another paper on connected and electric cars, but autonomous cars, sorry. Through the internet, they took over a car, and they could do stuff with it. Through the internet. This is very bad. Now, these two guys, which spilled the water on the stage yesterday, they show another problem. When we talk about hacking cars, people think, okay, let's steal it, let's drive someone off the cliff. But there's also a privacy issue with that, right? They showed, and spoke about it here, that your information is in the car and it stays there, even when you go away. And that's a big thing now, because it has your SMSs, your call history, your contacts. This is very private information, and then anybody else who has access to the car can get access to it. And then Tesla came out, and of course Tesla, it's all sexy, it's brand new, it's electric, and it was sure to get a lot of attention, and it did. This was the first, I think, public research. These guys actually took the car apart, you know, with screwdrivers and everything, and they tried physical access. They got, you know, very successful, but it was physical access. These guys, the Chinese guys, showed at Black Hat last year, again, remote attack on a Tesla. This is all, by the way, disclosed and got fixed. A Norwegian company, again, showed a different vector. Instead of hacking the car, they said, okay, well, if you unlock the car with a phone, why bother hacking a car, which is a new platform? Let's just hack the phone. So they hacked the guy's phone and stole his Tesla. It works, right? Two more researches that were published this year. Again, infotainment. This is a Dutch company. Infotainment systems that were found in Volkswagen and Audi cars made by Harman. Same vulnerabilities that the other guys found, you know, open ports and shares and code that was not supposed to be there. And then the Chinese guys went again, and after Tesla, they did a research on BMW. And that was also same problems again and again and again. And there are rumors, okay? No proof, but there are rumors that there has already been an attack in the wild, and people are just not talking about that. So we don't know. If you have any information, I would love to hear it. I will, of course, not name you, but so far, it's a rumor. Now, real-life pen testing, because some of you probably do that for a living, this is one of the services that Argus does, and I can tell you that so far, we've had 100% success rate. Every single time that we were contracted to do a pen testing, it was successful. Sometimes the objective is just code execution. Sometimes the objective is to inject messages on the CAN bus. As I mentioned before, you can do that and no one will know it's not you. You can do whatever you want. Not a single failure. This is how bad it is. And you don't even have to be a super hacker or have sophisticated tools. This dongle, which you can buy on eBay for less than $10, lets you connect to the OBD port, the onboard diagnostics. And you can query the car, you can test stuff, you can change stuff from your mobile phone. You don't need any training, any sophisticated stuff. This is like $8, sometimes even less. Now they have standards, okay? The industry is not just looking the other way. There are standards that are supposed to help secure the communications, but they are not yet as widely implemented as we would like them to be. And sometimes there are problems in implementation, which is, let's be fair, that you can find that anywhere in any product. But the big question is, what happens now? What can we, all right? Everybody safe? What can we do, right? Let's start by drawing the conclusions from what I've just shown you. We have published research that shows trivial problems recurring again and again, the same problems. We have old and unpatched software repeatedly used. Again, if it takes 5 years to roll a car out, you're going to have software from 5 years ago, right? That's how it is. And there are many logical vulnerabilities. It's not always about, exploits and 0 days and buffer overflows. No, sometimes you just plug in a USB drive and the car autoplays it. Logical problem, not an exploit. So not everything requires top-notch research exploit. In fact, you can be a script kiddie, and take over a car. Especially today with the internet, that everybody publishes their research and then the tools are everywhere, and it's really easy. Now, let's look at the economics of it, because economics are what drive crime, right? We all know that in cybercrime. And I will be comparing the IT security world to the automotive. Now, what is the cost of finding a vulnerability? In the IT security world, trivial and up, depending on the vulnerability. Some stuff is very easy. Some stuff you have to go, fuzzing, build fuzzing farm for years, months, weeks, whatever. It can be on both ends. And of course, in the automotive world, it's the same. Sometimes it's very easy. Sometimes you have to do some cryptography and to break a key. So, either way. But finding vulnerabilities is one thing. Exploiting them is another, especially when it is something like buffer overflow or, use of the free and stuff like that. So in the IT security world, it is becoming harder every day. And the reason for that is that we've had these vulnerabilities for so long that the market has already started to introduce mitigations, right? You had buffer overflow, so there was a data execution prevention, and then you have ASLR, and then you have... So there are mitigations that already exist in the technology. But in cars, not so much. So some of the vulnerabilities are trivial to exploit, and some of them take some effort. But it is not nearly as hard as in the IT security world. Now, monetization. Can you make money out of it? And this is, of course, the major question, because that's what motivates cybercriminals. IT security world, of course, we all know it's a solved problem. Crime as a service, you can do anything. There are so many ways to make money out of a hacked computer. There's even if you go to Brian Krebs' website, on the bottom right, there is a nice pictures like uses or things to do with a hacked computer. Many ways to turn that into money. In the automotive world, with the exception of ransomware and crypto mining, which apparently are platform agnostic, you can run that on anything from a smartwatch to a supercomputer. Right now, we don't see a good way to really monetize on hacking a car. And it's not just that. The big question is, can you do it at scale? So once again, in the IT security world, it's very easy to do it at scale. You just hire someone to write malware, and then you hire someone to build a botnet, and then you can have 100,000 infections in like 2 days. That's scale, right? But with automotive, not so much. It's really hard to do that. Now, I'm saying that it was proven but not witnessed because Charlie and Chris's research, they estimated that they could access about between 300 and 400,000 cars. The recall that Chrysler did was 1.2 million cars, right? So research has shown us that it is potentially possible to attack car at scale, but we haven't seen it yet. So I'm saying it was proven but not witnessed. And this is our luck. These two things, the things that motivate cybercrime, we are at the tipping point. We're at a very interesting moment in time where in the car industry, unlike almost any other industry in the history, or correct me if I'm wrong because I couldn't find an example, it is one of the few times ever that defense is actually ahead of offense. We are getting ready, we are gearing up, we're protecting cars before the armies are attacking, right? And why is that? Because of what I've just said. The current type of connectivity prevents attacks at scale. So it's not yet happening. Cybercrime is not yet there. And different standards and vendors, Fiat is using one thing and Ford is using another thing, and Audi is using another thing. So even if you have a code execution on some system, it's probably not going to work on another car. So this is all like, it's not worth it right now. And limited monetization potential altogether means attacking cars at scale and monetizing at scale are still not easy to do. So cybercrime is not bothering with that. When it becomes easy, then we're going to have a problem. But this is already changing. Connected cars, they all are going to have to speak the same language. Vehicle to vehicle, vehicle to infrastructure, they are all going to have to speak the same language. A lot of standards are coming out. Autonomous vehicles represent a new opportunity to monetize. Maybe you can hack a car and steal it. Now you have a car that you're controlling. You can do whatever you want. You can make bots of cars. If someone has a fleet of cars, maybe you can hijack the whole fleet. If it's a taxi fleet, maybe you can just, steal the taxis and run your own service and no one would even know. So there are new opportunities being created, and there's something called ECU consolidation. If before you saw 200 different ECUs, now they're talking about taking 5 or 6 ECUs and putting them in one computer. So now all of a sudden, if you get code execution on that computer, you no longer control one ECU, you will be controlling 5 or 6. So this is even more dangerous, right? So let's look back at this. Okay, that was a reminder of what a new car looks like. This is as complicated and sometimes even more complicated than the office of a small or medium business network. If you go to a firm, even this place, right? They probably have computers here running this place. SMB, small medium business, this is pretty much as complicated as an SMB. And in a business that relies on computers for their operation, someone will be in charge of security, right? Now we know that many times it's not a CISO, it's just some guy and they told him you do security, but there's awareness and there's a guy who's in charge of it. Whether he's good or bad is a different story, but someone is in charge of it. But in your car, there's no such thing. You don't even know what's going on there, and there's no one who takes care of your car all the time. Now the solutions already exist. It's not like we have to do anything from scratch. Okay, most of the technologies already exist in the IT security world because these are the same problems. What you have to do is adapt them. You can't just, let's say, take a checkpoint firewall and just put it in the car, because it doesn't work like that. Different standards, different networks, latency, different computing power. So you have to make adaptations. But the ideas, they're already there. You don't need to do the invention, right? So it's not that difficult. Now, the Argus philosophy does the same with automotives by importing the principles that we all know from the IT security world. First of all, you want to prevent as much as you can. Make it harder to hack. Right? Now, we know that prevention only works to a certain extent, so of course you have to be able to detect attacks on your car. Today, almost no one does that. Almost no one is able to tell you at real time that your car is being hacked. Now imagine the research that Chris and Charlie did. It took months of playing with ECUs. People crashed their infotainment 2 times, 3 times, had to go to the store to change it. Right? This happens. And no one knew anything about it. And the last thing you want to do, because at the point of the manufacturer or owners of fleet, you have many cars. If something happens in one of your cars, you want to know that, you want to fix it, and then you want to send the fix to your entire fleet, not just one car. Once again, these are the principles that we already know from the IT security world and are just being imported. And we talk about all that security by design. Everyone knows to say security by design, but it's not enough to say security by design. The person doing the security has to be a security person. To tell a developer, and if they're only a developer, now you're in charge of security, they can read books, they can take the SDLC documents. It will never be the same because it takes a special type of expertise that we as security researchers have to do that thing. So if you don't have a security person to do your security by design, that's okay, get somebody else to do that. Security as a service, it's not, it's not bad. We can do that. Hire someone, tell them, walk with us, accompany us, do the security for us, because it's very, very important. If you don't prevent the security at the design stage, you have to deal with them after deployment, and that's a lot more difficult and a lot more costly. Now, there's some legislation going on both in the United States, in Europe, and other places, and we're hoping that it will change things in 2 ways. One, the less likely, I'm ashamed to say, is deterrence by introducing all sorts of penalties. But as we know, criminals, by definition, they do not follow the law. So that's more likely to interfere with the ethical hackers and the researchers. But the other thing is, legislation is going to force the industry to protect itself. So it's going to elevate the security level of the products that we have. And this is what we're hoping. In California, there's also already a law that says that cyber has to be a consideration in designing of cars. So this is getting better. So, summing up, cars are sophisticated products, and like a computer network of a business, right? And we have to treat them as such, with respect and with security in mind. And there's no silver bullet, just like in the computer world. If you see a startup saying, we have 100% ability to stop all attacks, it doesn't work like that. It has to be layered security, detection, prevention, mitigation. And right now, guys, we are at the point where we are the little kid with the finger in the dike. It is up to us, okay, to keep that gap, to keep hacking cars and monetizing at scale at a distance, okay? Because once we fail, the floodgates will open, okay? If this becomes easy to hack and monetize cars at scale, then pardon my French, but we're fucked. Cybercrime is going to go in, and then we're going to see all the things that we're seeing in computers. And now, if you have cryptoware, maybe you lose a few photos, but if your car stops on the highway, you have a problem. Now, this is from me to you. The reason I'm giving this presentation is because we need more people to go into security research in automotive. And I know that it's not easy, and I know that you can't hack a car as easy as you hack a computer. You can just go buy a computer, and if you wreck it, it's done. But please consider looking for a job in this line, learn about it, because it is up to us, the security researchers, to push the industry forward. Because they will do whatever they can, but it's not their profession. And it is people like us who find these problems and report them that raise the awareness. And it's, again, like Mike says, it's all about community. We contribute to the industry, we contribute to ourselves, and that's pretty much it. I don't know if we have time for questions, maybe 5 minutes? I think I was running ahead of schedule. Or you can just, give it to the next person, because we're, yeah. All right. If you have any questions, I'll be outside. Thank you very much.